Hello, my name is Charlotte Lotze. In this video abstract, I will briefly summarize how ride-sharing with dynamic stop pooling can help to establish flexible and sustainable shared mobility. Today, the most common mode of passenger transport is individual mobility, where passengers go from their origin to their destination by a private car. These cars have a low average occupancy, and all individual routes sum up to a long route. Mobility could be much more sustainable. In ride-sharing, on-demand buses serve multiple users at once, driving them from their desired origin to their requested destination. The occupancy is typically higher, and in total, buses drive shorter routes. We introduced the relative route length that measures how far buses go in total compared to how far cars would go in individual mobility. Buses save route length when L is smaller than 1. How much route length the service saves depends on the concrete setting of the ride-sharing system, for instance, the number of buses. The fewer buses, the shorter is the relative route length. But passengers experience longer travel times due to other users. To measure the detour, we introduced the relative travel time that compares how long users travel with ride-sharing to how fast they would travel individually. With fewer buses, users travel longer. When we glue both curves together, we find a trade-off between relative route length and relative travel time when changing the number of buses. When a ride-sharing provider wants to save route length to make the service more efficient and more sustainable, they pay with higher user travel times and lose appeal. In this article, we introduce dynamic stop pooling. Users might walk to a close stop such that buses need to stop less often and drive routes that are more direct. Dynamic stop positions keep the bus routes flexible. We limit the maximal walk distance by a system parameter, the pool radius R. For each fixed pool radius, we find the trade-off between relative route length and relative travel time. But when adapting the pool radius, we save route length without longer travel times. In this way, dynamic stop pooling breaks the trade-off between relative route length and relative travel time and enables more efficient and more sustainable ride-sharing services while keeping travel times low. Do you want to learn more? For details, we refer you to the article Dynamic Stop Pooling for Flexible and Sustainable Ride-Sharing. Thanks for watching. If you enjoyed this video, click the like button and subscribe to our channel.